Hello and welcome back to episode 9 of Polynomials. Today we're going to be looking at the Quartic Formula that was discovered by Lodovico Ferrari in the 1500s. So first we are dealing with a quartic of the form ax to the 4 plus bx cubed plus cx squared plus dx plus, rewrite that again, plus e equals 0. And first things first, we perform the shift, which is we substitute in, for x, we substitute in x minus b over 4a. This is the same thing we did for the quadratics and the cubics, and we're just doing it again for the quartics. So if we sub this in for x, we will get a quartic of the form x to the 4 plus p x squared plus qx plus r equals 0. And what we're going to do next is we're going to take the qx and the r all the way over to the right hand side. So we're going to move them over here by minusing them. So we're going to write x to the 4 plus px squared is equal to minus qx minus r. Next, what we're going to do is we can add px squared plus p squared to both sides in order to complete the square on the left-hand side. So what we're going to do is we do x to the 4 plus 2px squared plus p squared equals px squared plus p squared minus qx minus r. And we can then factorise this stuff on the left-hand side, and we can make that x squared plus p squared, and that will be equal to px squared plus p squared minus qx minus r. Now what we're going to do is we're going to introduce a scrap variable z. So this just helps us with factorising. So we're going to add 2x squared plus pz plus z squared onto both sides. So what we're going to do is I'm going to write our x squared plus p squared, and then I'm going to write the other thing we need to add, plus 2x squared plus p z plus z squared. That is now our left-hand side, and that will be equal to 2x squared plus p z plus z squared plus everything else we originally had. That is px squared plus p squared minus qx minus r. And so now we can factorise again the left-hand side, because once again we've got a complete square. And so we can then factorise it as, just changing the colour of my pen, x squared plus p plus z all squared. And that will be equal to what we had on the right-hand side. So I'm just going to call that right-hand side. And what we're going to do now is we are going to factorise the right-hand side in order to make it a quadratic equation. And so I will say that that is equal to p plus z, 2z. I'm going to write that again because it's not very clear. P plus 2z x squared minus qx. I'm going to write the x in a different colour just to make sure we know it's a quadratic. Plus, in brackets, 2pz plus z squared minus r plus p squared. And we have a quadratic now on both sides. We have a perfect square equal to a quadratic. And if our quadratic is a perfect square, then we know that b squared minus 4ac must be equal to 0, because if the discriminant is equal to 0, we have a repeated root, but that also means we only have one solution and it is a perfect square. So we are going to write down our b squared minus 4ac next. And so that will give us q squared minus 4p plus 8z multiplied by 2pz plus z squared plus p squared minus r all equals 0. And what we're going to do now is we're going to multiply this out and then factorise. And what that will give us is, that will give us 8z cubed plus 20pz squared plus 16p squared minus 8r z plus, I'm going to write this on the next line because I know I'm not going to fit it in, 4p cubed minus 4pr minus q squared, and that is all equal to 0. Now, what we have is a cubic equation in terms of our fudge variable z. So, and this is called our resolvent, and what we're going to do now is we're going to solve for the resolvent and then continue to solve our equation. That's all I'm going to show you in this video. I will attach a full Quartic formula, in the description of this video. That shows all the substitutions and the Quartic formula in full. There are a lot of substitutions in it, and that is because if you tried to speak the Quartic formula, it would take about 4 minutes to say. Thank you very much for attending episode 9 of Polynomials, and I will see you all next time.